So the question which now I am gonna discuss is, does light bend? According to the Newtonian physics, light is consisting of particles which are called as massless particles, which are called as photons. But Einstein in the late 18th 19th century said that light is made up of waves. These are the waves. These are electromagnetic waves which have such trucks and peaks and trucks. So the question is that, does light bend? So we have to go from the core concept. So I would like to explain one activity. In this activity, suppose you are in a space shuttle. Yes, you are in a space shuttle and you are given a chance by NASA to go in the deep void, which has around 250 million light years in a far away galaxy. So suppose you are here and there is no window outside, and you are accelerating with acceleration which we will call hg. So now one more scenery is that you are on earth with the same rocket, no, without any window, and a gravitational pull exists on you, which we will say g, g1 and g2, where here g1 equals g2. You will not be able to get any differences whether you are accelerating upwards or downwards if you can't get any other field of view, relative field of view. According to you, what you could get, one according to Einstein, you cannot predict any way, or you cannot say any you cannot get any chance of getting that this one is different than this. But if you are watching our videos, then you may be knowing that the gravitation over here, see, what is the formula of gravitation? F is equal to g m1 m2 by r square. If you are here, means suppose this is the point of this is the center of earth. So from here the distance of this would be, suppose this is r1, and one distance over here, suppose this is r2, where r1 is smaller than r2. If r2 is greater, then here the gravitational force would be less, and here the gravitational force would be more. But it requires a very much calculation and much other instruments for measuring, so it is hard to predict where it is. But see, now one more instances with this satellite, with this rocket, you go in a deep space near that same void, and here is one laser pointing. Your acceleration, your velocity is greater than or equal to c. What is c? Speed of light, velocity of light. So suppose here you are in a cabin and you are sitting somewhere here, suppose, okay, let it be, my drawing is very bad. So as this point comes out, this appear to be going down. Why? Because I will tell this. If you are accelerating, you will see this, that light is bending. So why it is bending? Is light really bending? So the answer is no. So suppose this is time axis t, okay, these are a few instances, and one more is over here. So suppose the beam of light is somewhere here, okay, it has traveled some distance. Till the time the rocket also moves up. Why? Because it is in velocity. As soon as this time increases, also this time increases. This is the t-axis time. So as this time increases, the rocket spaceship also goes up. Now it has reached this. But our light is traveling here. Now after some time it will travel over here. If we join all these points, we will get a straight line. But if we go with calculus, okay, where so very deep fractions of the second, what you will observe, it's something this would be the scene. The light would be appear to be bending, but not. The spaceship itself is going up as this beam, a small beam is